The Pythagorean theorem involves geometric applications, and the proofs can be both algebraic and geometric, and some date back thousands of years. And the theorem itself says that a squared plus b squared equals c squared. Now, the a, the b, and the c describe a very specific relationship between the legs and the hypotenuse of a right triangle. And a right triangle refers to a triangle that has a 90-degree angle. Okay. Here are a few examples of right triangles, and notice that A and B refer to the legs of the triangles, and it doesn't really matter which side is A and which side is B, but C is always labeled as the hypotenuse of the right triangle. And the hypotenuse is the side opposite of the 90-degree angle. And notice too that the 90-degree angle is marked oftentimes with that symbol. So that's another hint of which side's the 90-degree angle, although you can usually visually see it as well. Now, here's one of my little silly favorite videos that I think will also help you remember and understand the Pythagorean theorem. It has a catchy little tune to go along with it as well.
Pythagoras is gonna show you why. A squared plus b squared equals c squared. C is the length of the hypotenuse. A squared plus b squared equals c squared. A and b are the length of the other sides. The Pythagorean theorem is a delicate calculation. To find the hypotenuse, take the square root of the sum of the two other sides squared, and then compute how do you find the hypotenuse's length if you know the length of the two other sides. Let's take you back to old ancient Greece. Pythagoras is gonna show you why. A squared plus b squared equals c squared. Well, c is the length of the hypotenuse. A squared plus b squared equals c squared. Well, a and b are the length of the other sides. A squared plus b squared equals c squared. Well, c is the length of the hypotenuse. A squared plus b squared equals c squared. Well, a and b are the length of the other sides.
I think I might catch a couple of you humming that come test time. Alright, so here's our first example that we'll work out together. If we have legs of 5 inches and 4.1 inches, and we have to find the hypotenuse x, we know that we have to use a squared plus b squared equals c squared, and we would square 5 squared and square 4.1 squared to get c squared. 5 squared is 25. 4.1 squared is 16.81. We'd add them up and get 41.81 equals c squared. And then we have to take the square root of both sides in order to get c. Now, at this point, you're really just going to use your calculator in order to determine that square root, and you can round that to approximately 6.5. Okay. Here's the next one. Notice here the missing side is one of the legs, not the hypotenuse. So again, we're going to use the Pythagorean theorem. We have a squared plus b squared equals c squared. So that means we have 15 squared plus b squared equals 18 squared. Okay. Now, it didn't really matter whether we plugged in 15 squared for a squared or b squared, but 15 had to be plugged in for one of the legs, and 18 had to be substituted in for c because 18 represents the hypotenuse. 225 plus b squared equals 324. Now, in order for us to solve this, we have to subtract 225 from 324. And that leaves us with b squared equals 99. We take the square root of 99 and we get approximately 9.9. Now, on this next one, we have legs of 6 inches and 8 inches. Oops. Let me go back a slide. And we need to find the missing value x. Okay, so again, we're going to use the Pythagorean theorem. So we would have 6 squared plus 8 squared equals c squared. 8 and 6 are our two legs, and x is our hypotenuse, so we know that we're looking for c squared. 6 squared is 36, 8 squared is 64. If we add up 36 and 64, we get 100. And if we take the square root of 100, we end up with 10 equals c. So our hypotenuse in this case equals 10 inches. Okay. Now, if we look at the second problem on this slide, it says that we are given a hypotenuse which measures 25 yards and a leg which measures 16 yards, and we need to find the measure of the missing side. Now, this is the first problem we've come across where we have not been given a drawing of a triangle. So I would encourage you to try to draw your own picture in this case. So if we draw a right triangle, okay, it says the hypotenuse is 25 yards and one of the legs is 16 yards. Now, I don't know which leg it is, so I'm just going to go ahead and label one of them 16, and I'm going to label the other leg x. Okay, so I know at this point that x squared plus 16 squared equals 25 squared. So 16 squared is 256, so I have x squared plus 256 equals 25 squared is 625. Now I need to subtract 256 from 625. Okay. And let me see where I can squeeze this in at. I'm going to get x squared equals 369. And I need to take the square root of both sides. And let me move up here. I get that x equals, and in my calculator I have 19.209372. So I'm going to round that to 19.2 yards. Okay. Now, make sure in these types of problems that your numbers are making sense. Remember that the hypotenuse is the longest side. So it makes sense that my answer is smaller than 25. If you ever came up with an answer that was larger than 25, which is your hypotenuse, something wouldn't be right. So it makes sense that my answer is 19.2 yards. Okay. And that's the Pythagorean theorem. So remember, the general form of the Pythagorean theorem is a squared plus b squared equals c squared. And that a and b represent the legs, and c represents the hypotenuse. You must use c for the hypotenuse. There's no negotiation about which side the hypotenuse is. It's always the longest side, which is the side opposite the 90-degree angle. But a and b are the legs, and there are two legs, so it doesn't necessarily matter which one you call a and which one you call b. Okay? And remember that you can only use the Pythagorean theorem in a right triangle, so it must have a 90-degree angle in the triangle in order to use it. Happy Friday, and don't forget to do your wraps to go along with this lesson.